Another day, another flag. Today, we're hacking into a hospital. It's a fake hospital, and this site was built as a perfect example of what not to do when designing your security. We start with a login page. There's a role for patients and one for doctors. A username and password was provided as a demo, so we simply log in as a patient. There's a bit of information here given about the patient and their medical history, but there aren't any buttons or anything shiny really. Using the tool Burp Suite, I see something juicy. A post request is being sent to /GraphQL, and with it, a JSON query. If you don't know, GraphQL is like a direct hotline to the database. To easier understand the database, I will be uncovering it on this map. First, we need to figure out what we can send to the website, what will be a valid request. Turns out, if the request is not processed, you can just query the whole schema. In other words, we can see all of the settings and all of the fields of the database. This is a known vulnerability with GraphQL, so someone has already done most of the hard work and has written the query for us. We just paste that in and get a huge blob of JSON in return. If you're unfamiliar, JSON is just a way to store data. Think of it like a filing cabinet, and each field is a drawer. It has a label and something inside it. Now, it's possible that another smaller filing cabinet is inside that drawer. We have a field called All Patients, and it refers to what a patient would normally have, a name, ID, medical history, yada yada, but what we're really looking for is this, passwords. To write our own query, we first have to put it in the right JSON format, which can be easily done with a script. We write what we want from the database, in this case the names and passwords of all patients in the hospital. The script converts it to JSON, and we just copy and paste that. Boom! Names and passwords of every poor soul that pays medical insurance. Now, you might notice something. All of these passwords are not regular human passwords, and they all have the same number of characters, 64 to be exact. This is because the best practice to store passwords in a database is hashing. And what we're seeing is a very common hashing algorithm called SHA-256. No matter how many characters you put through this algorithm, you will always get 64 characters back. It is a one-way street. You can hash something, but you can't unhash it. So even if I get all of these passwords from a database, I can't do anything with them. I can't log in with them. They don't work. Let's put that aside for now and see if we can get the passwords from all the doctors now. There's a field called All Doctors. It should have names and passwords just like the patients, but guess what? That field is emptier than my Tinder inbox. So no appointments, no data, no passwords. Well, we know that doctors have names. That's a given since we can see it in the patient data. This might be because we are logged in as a patient and patients don't have access to the All Doctors area of the database. But since we can see all the doctors' names when we look at the All Patients field, why don't we just add an extra parameter named passwords? That's exactly what we did. This time, we get all of the stored passwords from the doctors. Now, as I said before, these passwords are hashed with SHA-256. You have a password, you run it through the algorithm, and you get a hash. What's great is if you have the same password and you run it through the same algorithm, you will always get the same hash. By knowing this, we can essentially brute force the password. We just compare this hash to hundreds of thousands of other hashes and see if anything matches. If it does match, we'd know what the correct password initially was. As a side note, this would be the same as trying a bunch of passwords in the login page, but that would be very slow and the website would probably block us since it would think that we are DDoSing it. Instead, we can write a quick script or just go to an online decryption tool that does everything that I just said. Pop in your hash, it does a quick list compare, no luck. Just in case, let's try the hashes from all the other doctors while we come up with something else. I mean, the only other thing would be to get access to the backend and somehow... Oh, we got it. Turns out you don't need 7 years of medical school, just exploit some GraphQL. So that's it. Put in the name, password, log in as doctor, and we get the flag. If you want to see more, subscribe. Goodbye.